let's start. In that case, let's start. Hopefully, Elena and Mr. Akin will join us soon. So my name is Stanko Škec. I'm assistant professor at the University of Zagreb, and I can say that I'm happy to chair this session today, visual and haptic interactions with products. So I think that today we'll listen quite interesting presentations, which will be then followed with the Q&A and discussion session. I think that even by only going through titles, we can see some nice connections between these contributions, especially, for example, between first three and last two. And I believe that some of these relations will be able to emphasize and tease them out during the discussion. I think that we can learn a lot from different studies and better address individual aspects of own work, because here you throughout these presentations you will see that some contributions really nicely complement each other. Please, if you have any questions during the session, please write them down in the chat, or you'll be able also to pose questions after the presentation. Also, I would kindly ask you to especially the presenters that are sharing video and audio, that they mute their microphones during the presentations. So I believe then that we can start with first presentation. And before that, I would just like to introduce, hopefully she will join us soon, Elena Angeleska. She is from Skopje, from North Macedonia. She's actually a doctoral student at St. Cyril and Methodius University in Skopje. And she's working on her PhD thesis, which is actually part of the research project conducted as collaboration between Faculty of Mechanical Engineering Skopje and virtual vehicle company in Graz, Austria. So her PhD research is mostly related to autonomous vehicles, vehicle ergonomics, human-centered design, and design for inclusion. So let's start.
Hi, my name is Elena Angeleska, and today I will present the paper titled Design and Evaluation of an Inclusive Autonomous Vehicle User Interface Developed for Persons with Visual Acuity Loss. Automobile manufacturers invest in research and development to make self-driving cars a reality in upcoming years. The reason for this are the numerous benefits the use of automated systems can bring, among which the most important one is providing the opportunity for safe and independent travel to persons with impairments. In that sense, the most challenging task is to enable independent travel for persons with visual impairments, because most information provided to the travelers is in the form of visual cues. Therefore, when designing the inclusive user interface of autonomous vehicles, special attention and research is needed to provide equal usability, safe and intuitive vehicle-passenger interactions for persons who have a reduced sight. This research analyzes guidelines for designing an inclusive interface for persons with visual impairments, which are applied in the development of 3 wireframe options of a user interface intended to be used in a fully autonomous vehicle. The Wizard of Oz experimental procedure is chosen for evaluating the provided wireframe variants and choosing the optimal user interface layout. The method used in this research is described on the slide, and I will explain all these points in greater detail later in this presentation. So firstly, before designing the 3 user interface variants, the process began by developing the use case scenario for the autonomous vehicle and the possible vehicle-passenger interactions that might take place in an autonomous driving mode in order to determine the needed content for the user interface. And next, the elaborated inclusive recommendations were applied in the design process. The main criteria for selecting relevant guidelines was following the needs related to visual acuity loss. After selecting the general principles, there were several segments remaining which offered the possibility to be experimented with when establishing the differences between the 3 F wireframe versions. One part of the reviewed literature sources suggested a minimal use of text, replacing it with graphics and photographs. However, another part of the recommendations suggested using images relevant to the text and elements containing text and icons in combination. This was chosen as the first aspect that should be tested by the different app versions. Another point chosen for testing was the use of navigation elements that are always visible. This was in contradiction with using a large scale for all available options, since a fixed navigation window significantly reduced the remaining screen area available for other features. One more aspect that needed testing was the optimal positioning of the menu bar. All three developed models needed to offer a menu bar position corresponding to the user's mental models. However, the goal of choosing to provide menu position variations was to decide which position allows maximum usability for persons with a blurred vision. And these are the main differences between the three user interface variants. 10 participants in total were gathered for the experiment, and a Wizard of Oz autonomous vehicle was used, meaning that a conventional vehicle was slightly modified to represent an autonomous vehicle. The driver was hidden, and a tablet was mounted in the interior to display the three user interfaces and allow the participants to interact with the three variants. In order to simulate the visual impairment, the Cambridge simulation glasses were used, which create the illusion of a blurred vision. The testing procedure went smoothly. The participants were given instruction and 3 pairs of simulation glasses and were a part of 3 rides, each time interacting with a different user interface, and the order of interaction was randomized. At the end of each ride, there was a questionnaire and interview for the participants in order to collect their opinions regarding the design of the interface. The results showed an overall positive feedback, and variant number 1 was chosen as most intuitive, usable, and inclusive wireframe option. Based on this, there are some conclusions which were drawn. Firstly, the most important content should always be positioned centrally on the screen. Secondly, the navigation map does not need to be continuously displayed on the screen in order to liberate space for larger buttons and text. Thirdly, the text does not need to be included in the menu bar, provided that all icons used to describe the menu options are universal, filled with a color allowing a very high contrast and with sufficiently large size. Predetermined choice options are beneficial for persons who have a reduced sight. The design interface had such options for the comfort settings provided as choice buttons, and these were graded as most simple to use by the respondents. Dividing the screen into more than 3 sections is confusing and unnecessary because variant number 1 had a header, menu bar, and options section, which proved to be the most intuitive for use. There are some limitations of this research that need to be elaborated. The Wizard of Oz study simulates an autonomous ride. However, the ride in an actual self-driving car would be a different experience due to the exclusion of a driver and the appearance of the vehicle cabin. In our experiment, the driver was hidden, but the participants were still aware of his presence, which might interfere with the perceived feeling of safety. Moreover, the vision impairment was simulated through glasses, which helped to empathize with persons who have a visual acuity loss but cannot convey what it's really like to have an actual impairment. And another point is that the number of involved participants was limited due to the current situation with COVID-19, which makes it difficult to gather participants for an ethnographic study. Because of all these limitations, there is a possibility for further research on this subject. What should be done in the following phase is to optimize the interface based on the results from this evaluation and conduct a new study with a larger number of participants which have an actual eye condition. The new study can be conducted using a driving simulator in order to simulate a ride in an autonomous vehicle more accurately. In conclusion, we can say that it is hoped that these results from the study will help to improve the understanding of the design requirements for developing inclusive interfaces for persons with visual acuity loss. It is important to note that these conclusions are dependent on the specific type of visual impairment, since this research was focused on the particular needs of users with a blurred vision. However, these findings are not only applicable in the design of apps for autonomous vehicles, but also for standard vehicle models or interfaces with a completely different purpose. Thank you for your attention.
Okay, great. Now so the idea is that we first listen all the presentations and then we can have Q&A session and discussion session afterwards. So once again, I would like to remind you, if you have any questions, please just put them into chat. So the second presentation it will be given by Abhinav. Abhinav is a PhD scholar at design program at IIT Kanpur. He's working in the area of visual ergonomics of graphical user interfaces. He has deep interest in developing interaction-based experiences for users. He's mostly focused on visual design and also on improvement of visual interaction. So let's listen the second presentation of the second contribution.
Hi, this presentation talks about visual ergonomics for colorblind users in a graphical user interface. My name is Abhinav. I am a PhD scholar at Department of Design, IIT Kanpur, India. The research topic of this presentation is Universal Design Principles for Colorblindness. Visual ergonomics deals with creating environments that suit human visual capabilities, which is studied by examining the relationship between the visual capabilities of an individual and the task to be performed. It is an important aspect of interface design as it enables users to accomplish their tasks efficiently and comfortably. It makes sure that the information or the feature provided is clearly visible, properly understood, and easily accessible to the user. It assists user to respond correctly in less time. Universal design is a process of creating a product or interface that is accessible to the users with a wide range of abilities. The figure shown here is a normal distribution curve representing the presence of the user categories. The ones towards the ends of the bell curve are extreme user categories who have special requirements from the product or interface. If the product or interface could also cater to the requirements of an extreme user, it could be called as inclusive or universal design. Colorblind computer users have been considered as an extreme user category here, as there is a lack of good design solution to cater to the requirements of the colorblind users. The purpose is to understand the affordability issue faced by the colorblind's in a computer interface to come up with a universal design solution so as to make the computer interface inclusive to the colorblind users. Colorblindness is a visual disorder where an affected person cannot distinguish a particular color shade against another color shade. The image shows the visual perception in different types of colorblindness as compared to the normal color vision. Beside this is a graphical representation of color absorption curves where graph B, C, and D depicts mutated color cones. Survey containing an online colorblindness test and a few basic questions such as age, gender, and current occupation was circulated. 60 participants from all age group above 15 years of age took part in the survey, among whom 12 were found to be colorblind. The survey data is shown here. To validate the data collected from the survey, a detailed and separate sampling was done where the researchers approached all the students, professors, and staff members of IIT Kanpur in person, requesting them to take the test. Participation was voluntary. 100 college students and 65 working professionals took the colorblindness test. 13 out of 100 college students were found to be colorblind and 9 out of 65 working professionals were found to be colorblind. No female participants were diagnosed with colorblindness. The participants diagnosed with colorblindness were invited for a personal interview, and the questions inquired were like, were they aware of the term colorblindness? Do they know that they have color vision deficiency and its type? Did they experience any problem with colors? Problems they face while working on a computer? Were they aware of the color correction settings in a computer interface? And did they ever try to apply the color correction settings? Following is the response recorded. 7 out of 22 respondents had taken the colorblindness test before. Remaining 15 were unaware of their condition but faced difficulty in perceiving certain colors correctly. For example, green colorblinds had difficulty in distinguishing between shades of red and green, whereas red colorblinds perceived darker shades of red as black. No respondent knew the type of their colorblindness. When using a computer, they faced multiple issues with colors while playing games, shopping online, working with data such as pie charts, graphs, maps, diagrams, and so on. Only 3 respondents were aware of the availability of color correction setting. They had applied the setting before, but reverted back to the default color setting in no time. Affinity mapping is the method used for data analysis here, where the extracted interview data is categorized into clusters to identify the few most prevalent problems faced by the colorblind users in a graphical user interface. So the following insights were gathered from the interview responses. Most people with colorblindness are unaware of their condition. Configuring the color correction accessibility setting is a complex and unintuitive task in itself. Computers are a part of shareable interfaces, especially in India, where one computer is accessed by multiple users. It is difficult to retain the configuration setting for an extreme user. Here, the scope of design is redesigning the visual appearance of the graphical user interface by identifying the visual elements that could cause confusion to the colorblind users. eliminating the need of color correction, accessibility, customization, as this is a complex process, making the graphical user interface universally accessible to both users with color vision deficiency as well as normal color vision. To make the graphical user interface visually ergonomic for colorblind users, several visual components were explored for a possible design solution. Icon sets used in graphical user interface were found to be the most suitable visual component to enhance the user's experience. Therefore, iconography was chosen for design evaluation, considering colorblind users as subjects. Microsoft Windows 10 operating system was observed in this study as it has the highest computer ownership and all of the participants were familiar with the Windows interface. To evaluate the design of existing icon sets, the contemporary design was observed, where it was found that Microsoft uses 3 different visual styles for its icons in Windows 10 operating system, which causes visual inconsistency. Also, trend study was done to keep track of the current design trend adopted by the operating system. Based on the insights gathered and the design evaluation, a concept design is proposed. Here, a set of pictorial icons is designed to replace multiple icon sets as desktop icons and device icons that are present in Windows 10 graphical user interface while maintaining the aesthetic properties. Pictorial icons make use of symbols in graphical representation, which reduces cognitive load and increases task performance efficiency. Pictorial icons are single color icons, which eliminates the possibility of confusion caused by contradictory colors, thereby making the icons inclusive to the colorblind computer users. To assess the performance of the design concept, 2 sets of mock user interface of Windows Desktop and Device Manager were developed, one with the existing icon set and the other with redesigned icon set. All 22 participants who were diagnosed with color blindness participated in the experiment. All participants were asked to perform 5 tasks on each prototype with both icon sets, and the responses were recorded for comparison. The task performance efficiency increases by 1.5% when using redesigned icons against the existing icons on the desktop prototype, whereas there's a massive 12.84% performance boost when using redesigned icons against the existing icons on the device manager prototype, as shown in the graph. This confirms that the pictorial icons provides better efficiency where precision is involved. So it could be concluded that pictorial icons greatly help enhance the task performance efficiency of the colorblind computer users, and it eliminates the need of color correction accessibility settings, as the same visual component is universally accessible to both users with color vision deficiency as well as normal color vision. Thank you.
Okay, nice, great. So now we have Emanuel Balzan. He's a PhD student from University of Malta. He's studying the design of therapeutic toys for speech and language intervention. Also, in the past, he worked in the automotive and marine industries, and he successfully worked on previous project called Speechy, where he developed or he participated in developing smart device for supporting children with language impairment. Also, currently, he is engaged in Horizon 2020 project involving VR and rehabilitation. So let's listen his presentation.
Good afternoon. Welcome to this presentation titled Evaluation of an Affordance-Based Requirement Generation Tool for Speech and Language Therapeutic Toys. My name is Emanuel Balzan, and I will be presenting this paper on behalf of my colleagues at the University of Malta. The motivation of this research concerns speech and language therapy among preschool children. 7% of the global childhood population possesses a language disorder which cannot be attributed to any causative health factor. And currently, there are no specifically designed speech and language therapeutic toys that address the needs of clinicians, caregivers, and children. And basically, my research concerns the development of a design support tool that helps designers elicit requirements for such artifacts. This means that support will be provided during the task clarification stage by equipping designers with domain knowledge for speech and language therapy. The objectives of the study is to evaluate a computer-based tool that was developed for this purpose. The computer-based tools development framework of Duffy and O'Donnell was used as guidance. The tool that the study is concerned with was based on 2 information models developed through previous studies after the designer's reality and different phenomena were investigated. One of the information models is a prescriptive, user-centered design framework that maps customer needs into affordance-based requirements. The other is a requirements ontology for the speech and language therapeutic toys. This ontology was created through several interviews and focus groups with therapists and parents, and was later validated by clinicians. So the support tool was called Acquaintsalt, and here you can see some screenshots of the main interface. It has a main menu which allows designers to start new requirements elicitation projects. At the top of the screen, there are 12 tabs corresponding to the previously mentioned ontology. These are buttons by which the selected items on the screen are saved and translated into affordance-based requirements. One can also generate further requirements by looking at existing products that match these criteria here. These requirements being shown were extracted from the marketing description of the products found on a leading e-commerce website. So any desired requirements are added to the list of affordance-based requirements being generated. And these can be viewed within the tool, as can be shown here. The formalism of affordance-based requirement statement was adapted from Cormier et al., where each statement states that the product being designed affords the user with a particular user characteristic, a type of affordance with respect to a target entity within the environment. As you can see, some parts of this formalism are optional, but the more detailed a requirement is, the less ambiguous the statement is. In this evaluation study, 14 international toy designers with industry experience ranging between 4 and 30 years took part. After explaining the background of this research, a 1-hour-long demonstration of Acquaintsalt was provided, and then a semi-structured interview followed to evaluate the tool and the framework it is based on. Thematic analysis was then carried out, where all the interviews were transcribed, read multiple times, and coded until a total of 5 overarching themes emerged. So the first theme was about affordance-based requirements. Essentially, 65% of the participants had never heard about design affordances, but all designers agreed that affordance-based requirements are straightforward. The participants were very satisfied that a detailed list of requirements can be generated at the end of the process, and that the marketing description of matching products can be used to elicit further requirements. The findings of the second theme were that Acquaintsalt is helpful to both novice and experienced designers, and that it supports the activities of the task clarification stage. Moreover, the tool motivates designers to improve the product being designed by encouraging them to explore unforeseen requirements through existing solutions. Differences in the way the participants work were noted, and this led to the definition of the third theme. The designers appreciated that the tool organizes the requirements elicitation process by letting them choose which aspect of the therapeutic toy can be considered. Some said that they prefer to go through all the categories, and others preferred to check a few categories first and then revisit the other categories at a later design stage. This finding shows that tools should not restrain designers in the way they work. Through the fourth theme, the designers' willingness to use the tool was captured. All the designers said that they would be willing to use it to generate requirements for speech and language therapeutic toy artifacts, mainly because they usually find it hard to access key experts for unique kinds of toy products. The fifth theme focused on features which the participants particularly liked and others that need improvement. Among their preferred elements in Acquaintsalt were the ability to automatically generate requirements based on predefined personas, the ability to see the generated requirements as the designers interact with the tool, and the presence of tooltips which explain every area on the user interface. In terms of improvements, the participants suggested having more knowledge bases that would support their decisions and the ability to specify technical specifications. One limitation of the study is that only 14 designers participated. However, replies from more experienced designers agreed with those having less experience. Yet, the most significant result was that the designers would be willing to use a design support tool for the task clarification stage, a stage for which up till now they never used any supporting means. As conclusion, this contribution showed that the framework and the prototype tool would open barriers to developing speech and language therapeutic toys. In terms of future work, Acquaintsalt will be improved based on the suggestions of the participants and the framework on which the tool is based on. This framework highlights other features yet to be implemented. Here is a list of references used in this presentation. Note that this research was funded by the National Research Funding Programme of the Malta Council for Science and Technology. On behalf of my colleagues, I thank you for your attention, and I look forward to answering any questions you might have.
Okay, and now the following presentation was recorded by Professor Bastian Quattlebaum. He is Professor of Quality Management and Textile Testing, and his expertise is related to use of quality management methods and actually quantification of subjective customer opinions. Of course, all these within the context of sustainability and digitalization.
Hi everyone, welcome to our presentation. Due to the time, let's jump into the topic. The background of our research is the perception chain. And we have to understand we have objects and they emit signals, which we call stimuli. And then we as consumers start our recording process. And first of all, we have a kind of a process step which is called transduction. So we convert the stimuli into a pattern. Then we process what we see, hear, touch, whatsoever. And we have so much information that we can't process everything. Therefore, we filter effects out, like with the attribute dominance or halo effect. Then there's coming the perception process. That's the aware coming of what we perceive. After the process of perception, we have the association, which means we connect it with certain experiences we already made in the past, and connected together. And based on this connection, we go into action and response on this stimuli. And then we go around in this circle. And now with what we are talking now we want to cut off some of these sites we have in the perceptions chain, because we only go into the visual representation, but we have experiences in all of our perception chain and sites. And therefore, we want to understand how can I perceive the haptic site just with looking on it visual and presenting by visual cues. To tackle this challenge, we proposed the following methodology. First of all, we did a haptic study with a smaller scale of people, around about 10, and we wanted them to individually evaluate materials haptically. And they should define attributes, they should define test instruction, and they should check that the attributes are working. Then we take these information out of the physical haptic study and put them into a digital study. In the digital study, we only use visual cues, which means we present pictures of high resolution, we give an introduction, probants should do the attribute assessment, and we collect, of course, socio-demographic information. And afterwards, we do statistical analysis and check what is the difference between the haptic study and the digital study, and do these attributes work just on a visual cue side. Let's see what we got out of the haptic workshop. First of all, we had 10 persons of different gender and age group, and almost no one of them had textile experience. We showed them 14 different textile materials, which you see here in the bottom. And the only thing the people were allowed to do, they were only allowed to feel or touch the materials. So we covered them behind the wall, and so they only could grab through it. And then we asked them to verbalize their associations, their sensation, touches, and write them down so that we could discuss them later. After every of the people had the chance to individually check the materials, they met together and had a joint group discussion where they defined haptic-related attributes and with individual scales, so that they said, okay, if I'm in an attribute, what is the smallest value of a 10th Likert scale, and what is the biggest value? And afterwards, they derived also haptic test instructions where they said, okay, if you have to evaluate this attribute, then please follow this instruction. They established 8 different attributes: strength, wool, softness, felt, structure, ease, elasticity, and smoothness. And there you see on the picture on the right how they discussed it together, what were the different attributes or different wordings they used, expressions, and how they clustered it together. And at the end, there was a short definition which says, okay, strengths, if a material is solid when it is dimensionally stable. As described in the methodology, the results of the haptic workshop were then used for the digital study. Within the digital study, we had 82 participants, ranging age-wise from 18 to 50 plus, and they were quite good split within the gender. Again, they saw the 14 different textile materials, but this time they only carried out a purely visual perception of these haptic properties. So we showed them a high-resolution picture. And the leading hypothesis for us was, is the haptic and the digital sample identical in the population? At the end, we wanted to check both studies together and see what came out with the attributes. We can say the attributes worked, the scales were applied goodly. We wanted to check are they independent from each other or not. For this, we did the correlation analysis with the Pearson correlation index. You may all know greater than 0.8 or lower than minus 0.8 means real strong correlation and connection from each other. Here on the left, you see none of these value is above or below 0.0 or minus 0.8. The strongest correlation we see is between wool and felt. On the other hand, we wanted to check what is about the hypothesis. Are these populations, the sample populations, can be classified as the same between haptic and digital study? This is what we've done with the Levine test and the t-test. And you see here that the significance greater than 0.05 leads to that the variance is the same, and therefore wool, softness, felt, and smoothness can be classified as this, that the perception for these attributes, the participants have the same perception between haptic and digital study. And therefore, we can also say that strength, structure, ease, and elasticity, on the other hand, are highly insignificant with each other, and therefore the hypothesis, null hypothesis, needs to be rejected. As a conclusion, we can say that the implementation of this haptic and digital study proves that it's possible for customers to perceive haptics with just visual cues. We saw that 50% of the attributes could perceived equally in the haptic and the digital study. Now we have to do some more exercises on different materials, get different characteristics, and examine them via the digital media. And for comprehensive quality management or also development approach, we think we have to move also away from just pictures to investigate and also into 3D and 4D simulations.
Okay, and the final and last presentation, of course, not the least, will be given by Rakin. He is pursuing his PhD at Department of Design at Indian Institute of Technology in Hyderabad, in India. And his research is focused on the effect of haptic perception on the design of textile composites.
Good evening, everyone. Let me introduce myself. My name is KV Rakhin. I am a PhD student in the Department of Design, Indian Institute of Technology, Hyderabad, India. As you can see on the screen, today's topic is understanding the role of perceptual haptic condition in design decision. My talk is relevant to those conceptualizing the reliable touch-sensitive interpretation within domain knowledge in textile design decision. Therefore, within the perspective of design decision, our study examined the need for control over visual cues to assess the haptic properties of fabric. First of all, I will begin with the study context. Design cognition penetrates two states of the signaling process. One, the processing of sensory information called perception. Two, the evaluation of representational content in the context of reasoning known as cognition. Here we have considered the following sensory condition. The vision. It identifies the position, shape, binocular disparity, motion, and 3D layout of an object. The haptics. It recognizes surface properties, compliance properties, weight, and temperature. A combined haptic visual condition. In this stage, both function as two different sensory channels to perceive the same modality. Within this context, we consider a case study of automotive upholstery fabric design. We know that the described seating surface slips and stress on the driver posture. Therefore, we think that the haptic design of upholstery fabrics must improve the slip resistance. At the same time, visual adaptation is usually an essential method of design presentation. If so, we have raised two questions here. How can the designer ensure that fabric surface is appropriate for driver's posture? Do the subjective evaluation reactions lead to change in the design decision? Next, I focused on how case study research can be applied in practice. We developed a 5-stage haptic rating process. First, the measurement method. The semantic differential method makes it possible on a 1 to 5 scale. For example, 1 is considered extremely slippery, while the 5 is extremely grippy. Second, a specially designed black-colored box. It can be used to control the haptic task condition. Third, hand-finger movement guidelines. According to the guidelines, a single layer of fabric holds between both thumbs and forefingers. Then gently press the fabric and pull the thumb and forefinger in the opposite direction. Repeat this process and feel a stick-slip phenomenon with a jerking motion. Fourth, the final calculation of the haptic rating. Fifth, the report card. It represents the subjective touch sensation of the specimen. Now we move on to the case study methodology. Our case study is based on psychophysical experiments. According to this methodology, the finger forces acting across the fabric topography cause the coefficient of friction. In this way, it conveys the feeling of effortless gliding, indicating slipperiness, while increased adhesion suggesting grip. Let's see a brief description of the experiment. We used 113 texts and 290 GSM herringbone polyester fabric. The experiment was conducted under 1. Touch alone, 2. Vision alone, and 3. Combined visual haptic. According to the experiment protocol, we ensured that all participants washed and dried their hands. The experimental room was set up with a controlled lighting environment. Response feedback recorded in the computer. There was no time limit for feedback, and an informal interview was conducted. Minitab version 19 was used to calculate the responses. Now, I would like to talk about perceptual cues encoding. We hypothesize that perceptual cues act as a mode of communication. Verbal descriptions in English language are taken in to encode the sensory cues. Also, the descriptive groups contradicted each other. And then I will proceed to some highlights of the statistical analysis. Regression analysis shows that in the haptic salon task, both groups were significantly sensitive to slippery grippy at 46.69% variation. In the visual task, 8 visual cues were observed that about 25.44% of the variation in response by look. In the combined visual haptic task, the variation in feedback after look was about 52.53% and about 57.5% variation by touch. The visual haptic matrix shows that look and rating is a weak negative correlation. At the same time, touch and rating is moderately negative, but statistically significant at 95% confidence level. The overall results shows that the changes in the mean value of visual perceptual responses increases, the mean value of haptic cues decreases. The comparison shows that haptic cues are more dominant than visual cues, although visual cues almost followed the haptic path. This leads directly to my next 4 points. Point number 1, we found that without the full awareness of the perceivable, visual cues can quickly dominate design judgments. 2, in such cases, it affects the ability and the performance of the desired design when choosing alternative. 3, our study also shows that vision regulates relevant facial information through hand-finger movements. 4, the high cognitive load tries to divert the focus of selective design attention, resulting in poor decision making. Let me briefly summarize what I have said so far. Our study shows that optimizing the prolonged haptic interaction is essential when designing upholstery fabric for automobiles. Thus, we propose that designers subjectively evaluate the fabric prototypes for better haptic performance. And finally, I would like to emphasize following points. 1, our study represents real human subjective touch sensation of textile products. 2, we define quantitative values for textile touch sensations. 3, we standardize touch-related adjective words that enable proper communication across the textile supply chain. 4, we facilitate distinct haptic feel instead of overall fabric hand. 5, we also focus on standardizing prototypes for haptic requirements of specific textile products. 6, Our study supports a self-assessed touch quality management. 7. Our study facilitates R&D in haptics of textile products to characterize the responsive user touch interaction. So, this concludes the focus of the discussion today. It's an honor to have the opportunity to address such a distinguished audience. Thank you.
Okay, great. I think that we heard some really interesting presentations, and potentially I think this could lead to very a nice discussion. I noticed that some of you already inserted questions in chat, which is really nice, and maybe even I think this would be a great starting point for discussion. So now I noticed that Elena joined, so I'm not sure whether she's able to communicate. I think that now we can unmute mics and we can discuss. So the initial question was posed by Bastia about diagram that show differences of the three variants and actually related associated judgments. And he commented on very small differences. So could you please, Elena, describe this a bit more?
Yes, I'm here. Can you hear me?
Yes.
Thank you. Okay, thank you for the question. It's true that the differences were not very drastic between the three variants. And firstly, that is due to the limited number of participants really in the whole testing procedure. And also because they all received high scores on the Likert scale questions that were given to the participants initially. Afterwards, during the interview session, after the participants answered some of these questions, the main differences between the three variants became evident, and what is the weak point and what should be used for designing inclusive graphics for persons that have a vision impairment was drawn as conclusions. So regarding the diagrams, that's why they are very close regarding answers, but then during the interview session it was very beneficial to hear what they prefer. For example, they did not like having a navigation map constantly available on the screen, because then all other content was very smaller, and due to the simulated blurred vision, they weren't able to see some of the text which was smaller on the screen. So I think this answers the question pretty much. I hope I answered that. And
thank you very much for the answer.
Okay, so we have one more question, Elena, for you, and I think this is also a question which can be potentially posed to some others as well. So please, I'm looking forward to other contributions in terms of responses from the other members. So Chris commented that you focused on screen-based interfaces. So have you considered using a more tactile interface with physical feedback? So let's say to a certain extent to address multimodality. As you mentioned in your paper, that it's one of the common approaches for addressing this type of visual impairment. So have you considered some other modes, and especially focusing on physical feedback?
Yes, definitely. So this is a very, great comment, because that's what's recommended always when we are discussing the needs of persons who have a reduced vision regarding the use of interfaces. It's always a suggestion to use a multimodal combination for communicating. So this part of the study was mostly focused on testing the initial design for the graphic interface, and that is why the focus was to withdraw conclusions regarding the optimal layout and to see what size of text should be used, what type of icons, what arrangement and content. And we are currently working on further researches. So we have an optimized version of the graphical interface, and now we're working on using combination of the graphical interface together with some sound notifications and potentially some seat vibrations. So we are intending to use a driving simulator to simulate such a ride in an autonomous vehicle, where we can combine the graphical interface, some sound notifications, and also tactile notifications, so that we can see if it is more beneficial for grasping the attention and communicating with the persons who have a vision impairment. So hopefully we will have more results regarding this topic in the upcoming future, maybe for a future paper.
So since now you mentioned graphical user interface, I would like to involve Abhinav, because I think he could help us here. And I mean, he also addressed this issue in his thesis, but also in this specific paper. And here, what I would like to ask is actually, so Abhinav, could you relate your work to the initial presentation?
Yes.
And
I would like to answer this question.
Could you address some of the aspects that were mentioned regarding visual blur, what Elena presented in her paper?
Yes,
because I mean, visual blur is often considered as the one with the widest range of specific UI requirements. So could you, Elena, help us on that? So how would you incorporate that in your research?
Yes, I would first like to
we cannot hear you, unfortunately.
Is it audible now? Hello, is it audible now?
We can hear you.
Yeah, okay. So I would like to answer this in context of color blindness first. Like in digital interfaces, we use color filters, color simulation filters to understand the color vision, color perception of a color blind. So in case if we want to make a design universal for the different extreme user categories, we need to design a product in a way so that it could be equally visible to all user categories. For example, if we consider this in a tangible interface, we have the symbols for identifying vegetarian and non-vegetarian product in India. So earlier it used to be a green dot to represent vegetarian food items, and red dot to represent non-vegetarian food items. Now what has happened, we have replaced, I'm not sure whether it has been done in other parts of the globe, but in India we are now utilizing red triangle to differentiate red triangle for non-vegetarian items, so that it could be easily distinguished by the colorblind users. And regarding, I haven't worked on the visual blur. I haven't targeted such extreme user categories, but that could be an interesting study.
Because what I was suggesting actually is that you have different icons that you use, so potentially this could also be nice help and support also for Elena's work, because you focused mostly on icons in your study, while Elena, this was actually part of her work. So that's the reason why I think that this could potentially be interesting. What I wanted to ask, and now I would like to involve Emanuel. So do you think that actually your taxonomy / ontology and your framework could be modified and reused for visually impaired users? I noticed that they're quite abstract. They have quite abstract constructs in your framework and taxonomy. So do you think that you could reuse it and modify it?
So good question, Stanko. Basically, my ontology takes care of this aspect. It is called the accessibility aspect because it takes into consideration universal design, basically. So what this tool would help designers do is to consider any impairment, because we can have multiple impairments, not just visual, not just haptic, not just motor. So it would give you an indication of the level of impairment that you have. So I believe that designers need to have means by which they are aided and be aware of different levels of impairment so that they cater in their design.
Okay, great, thank you. Just I noticed that we have some questions also for presentation 4. Question posed by Yuri. Bastian, does your study have any implications for e-commerce, as the visual perception is able to a good extent to replace the feeling of real fabrics? But I think this is something that Rakin could also join to respond that as well.
Yeah. Thanks for the question. And of course, e-commerce and especially returns caused by e-commerce and false orders are our main objective while we're doing this. So because not just due to COVID, it was also before. Especially for textiles, most of the orders and most of the business done due to e-commerce, and therefore we want to understand how to bring more information to the customers, because the two main reasons for the returns is either textiles do not fit or either they touch badly if you get them. So that do not fit, we do 3D scanners, LiDAR cameras, iPhones 13s and whatsoever, and get our fancy 3D avatars and try to get the Fitbit away. And the other bit is how to get haptics and touch feeling into the digital world. And that's why we're doing this. And our approach is, first of all, to understand in the semantics of the customers, how do they describe the haptics. Then we try to find out how to represent it in the digital world. So our next step is to get more details in pictorial information about the different textiles. So have deep microscope scans, have better high resolution pictures of the textiles and represent it to the customers so that they can really distinguish on these different attributes. And we like to also try to find out what are, we call it artifacts. So if you think about softness, what are your first association artifacts you associated with these attributes, and that we can link it with different pictures again to the textiles, and so that we get more comprehensive information about the haptic touch to the material, and so that people can better assess visually on visual cues what a textile could feel. And this is what we are working on. And this study was the first step towards it. And we do it now with different materials. We do it for clothing and fashion. We do it for automotive materials, interior materials, and so on, because also these products go more in the digital e-commerce channel. And maybe I just grab on the next question with Chris was posting, because he said what is with other like sound or what we can do, and of course sound helps, as every multimodal experience will help, because we have our experience-based set on this one. We learned already that sound could support it. We are not quite sure yet how, or we didn't test it yet to bring it in an e-commerce or in a digital channel to record the sound of interacting with the material, because it's also very dependent on the different skins of the people, and therefore we are not quite sure yet how to standardize this one. But sound could be an option doing it. And also, that's what I mentioned in the outlook of the other ones. On top of it, could be also with movement and picturizing and doing what you're doing, recording what you're doing on a haptical wise to present this to customers on top of it. So therefore, a combination of different sites within the digital channel would be beneficial and helpful, of course.
Great, thank you, Bastian. So Rakim, could you maybe respond to these 2 questions as well? So to hear the way you see it.
Yes, please.
Yeah, so the first question is actually, so do you think that in terms of e-commerce, visual perception can be to a good extent good replacement for feeling of real fabrics? What do you think about that?
Yeah, in that case, is actually the shops presently the shops, the customers are directly go to the shop. This is one of the main reason, because if you are depending on these online products, so many of them are unable to understand it, what is the exact feel. So that's why in technological wise, if it is improved, that will be much better into the e-commerce platforms.
And related to the second question, do you think that sound could be added and actually helpful to, for example, designers or textile designers or engineers?
Yeah, of course. That is one of the options. But in my research is focused on how the visual and haptic is having the interfaces. So that's why I'm not concentrated in my studies. But that is one of the good options so that we can be considered in the future works or something.
Okay, great, thank you. So
Yeah.
what I would like to ask. So yes, there is one more question for Bastian. So did all participants apply all three tests directly following each other in a row?
Yeah, definitely. So we considered all these three tests. One is purely in visual, another one is purely in haptics, and both combined. So all the participants are participated in all three tests, and all the feedbacks we received and we analyzed.
Did you see any learning effects? So because they already had an interaction haptically first and then carried into the other settings?
So can you please repeat? Your audio is not clear.
Did you see any kind of learning effects because they already interacted with the first test setting and representation and then went with the next pages? Did you see kind of differences in their judgment?
Yes. We observed some of the differences in their feedbacks. The things is that they became more confused once it is related with this visual and haptics together, because most of them are taking our questionnaires very lightly, because while seeing itself they will be come to a conclusion. So this is the material and this is the sensation maybe. So very few of them are having most interestingly to deeply into that process. So that difference is really reflected in our results.
Thank you.
Okay, great. So now I have one question for all of you. Since I noticed when I went through all your papers that some of you are focused mostly on qualitative research, some of them mostly on quantitative. And since you're mostly tackling issues related to subjectivity, related to perception, I wanted to ask you, how do you combine these things, and how do you actually choose whether you want to use qualitative, semi-qualitative, or quantitative approach? And if you could comment also sample sizes in your studies. So we can go, I don't know, in sequential order. I don't know, for example, if Elena can start.
So I'm not sure. It depends really on what we're aiming to examine. So a combination of both is, I think, in my experience, best. And regarding the sample studies, I think that in my case, it was too small, the sample that was used, and larger samples are always more beneficial. So I think that only more than 10 participants was too little, but due to the many limitations we had at the moment, this was the only number we could include. However, I believe that for receiving significant data, I think that above 30 or 40 participants is much better choice. I don't know if the others would agree with me. It depends on the type of study. So what we were trying to analyze was the graphical interface, and another limitation in my case was the simulated vision impairment. So
what we're considering next is using a larger sample and people with actual eye conditions. So not only simulated vision impairment, because you cannot really simulate what is really like to have this issue in everyday life.
Maybe I agree with Elena that it's a combination of both, and depending on the purpose you're asking for. So I think if you're in this information gathering understanding phase, it's more qualitative. And this is also what we did with our workshop, and we try to bring then a broader scale of people into it. And then if we want to prove what they told us, we go into the quantitative ones, and sample size numbers is always difficult, especially if you're talking about subjective sights assessment. Every people are different, every eyesight is different, every skin is different. So we aim always above 100, but even though, if we are honest, 100, depending on or comparing to 80 billion Germans, for example, 100 is nothing, but better than nothing. So we aim at least always above 100, and then it's when we want to prove something in detail, we will move over to quantitative ones.
And in user experience design, it is established by Nielsen and Norman Group in their website that if sample size is above 20 or 25 participants, it tends to provide similar results. Even if you extend it to 40 or 45 participants, it will yield similar results.
In my case, I mean, obviously, the larger the sample, it's always the better. I carried out studies which involved 60, hundreds of children, but this one that I presented today involved only 14 designers. So I had to mix both quantitative and qualitative data and try to, augment what they said with the quantitative value. So that's, sometimes when you lack number of participants through semi-structured interviews, you would get more feedback, and they would start to recall experience or talk on behalf of other participants or designers in my case. And so that, kind of augments the data set that you have. For sure, the current times did not help anybody because interviews had to be carried out online rather in person in some cases. So every feedback is relevant, and you try to get the most of it.
Rakim?
Yeah. So actually, for me, I'm also agreeing with the previous presenters what they commented on this, because we had to be campaign this qualitatively also. But the main thing what we are facing the difficulty is that using the proper words in the qualitative way to the people, so they have to be responded. So in that cases, what we did, we just given a brief description that what word we had to be using for our studies. For example, smooth, rough. And another example, I can say that one of the studies by Kawabata, that is from the Japan. So he's used for the fabric hand evaluation. And he used basically some of the Japanese words. Still, it is translating into English. So many of the meaning is getting different. So this kind of the points we have to be considered here. So we just make to the participants that this is the exact word and or otherwise the definition of that word we are using into this research. So we are concentrating on such kind of the points. We can be campaigned very well into the qualitative, because basically many of the haptic design research is based on that psychophysical experiment. So that will be campaigning a small part of the qualitative research also.
Okay, thank you. I mean, my question is also, mainly aiming, because when you go through all the different papers, you will realize you have different sample sizes, and you responded you respond the same thing, but there is actually quite variety in sample sizes. And also in terms of qualitative and quantitative research, I definitely agree with what Bastian said, that the potential qualitative research is mostly for explorative one, and for the verification stage, let's say that some of these things could be conducted in quantitative manner. So I mean, my question is also because actually how you selected sample participants potentially could influence your for example results. So for example, Bastian, you had study with 10 people that haven't had any previous textile experience. Would you say that with for example, with changing the initial sample, you will have different set of characteristics, initial ones, or you would say that probably wouldn't happen?
I believe the attributes we would have gathered, the top naming would be the same. The further on detailed description, if they would have been textile expertise, they wouldn't be in the customer language anymore. They would be too expertise. So therefore, I think the overall category would be the same, but the language we were looking for would have got lost if we would have taken a different sample constitution by experts.
Okay, thank you. So I have one more question for Emanuel. I noticed that you developed your own tool in a way, so based on the initial framework and taxonomy. So have you maybe, I mean, due to that, you had to develop your own user interface. And what I want to actually ask you is, have you compared it with, for example, some other requirement management tools? I don't know, are you familiar with, for example, doors or tools like that, which are actually not only for identifying requirements, but also to managing them throughout the design process? So have you maybe checked and compared, did some kind of benchmarking with the requirements management tools?
Not really, Stanko. I have not considered that, but it's a very relevant question. The thing is that I had to convert normal customer needs into affordances, so that it gives designers more quality in terms of customer needs. So from the literature review that I carried out, there wasn't such tools available, and I cared for that gap.
Okay, and one question related to that, in a way, it's also inclusive design, but in your case, it will be actually to address more needs of novice designers. So, for example, how would you adapt? Because you said, based on what you wrote, what was written in manuscript, is that mostly it's easier to use if you're experienced designer. So, if you're a novice designer, potentially they have some difficulty. So, how would you actually address that?
So, basically, what the outcome of this research was that, the more support that designers have, the better. Like, since there was the aspect of it was more heavy on the textual side of I was muted, right?
Could you please repeat?
Yes. So basically, the outcome was that designers said that it's more useful for more experienced designers than the novice ones, because it's heavy on the text, and novice designers would require more examples, more illustrations. So it is useful for both. So what I was going to say is that any designer would benefit from it, because any support is helpful. And the more easy you do it, the more it would help novice designers.
Okay, great, thank you. So, and one question now aimed at both first and second presentation is, so I would like to ask you, so do you think that your propositions could be also useful for mainstream users, not only the extreme ones. For example, Abhinav, you showed the consistency across different icons used in different types of for example, Windows operating system. So do you think that this could be also useful for mainstream users and not just only, let's say, colorblind users?
Yes. So the objective of this paper was to make the design equally accessible to both users. So it is actually helping both mainstream users as well as extreme users in a similar way, so that both can use equally use the interface with the help of those icons, pictorial icons that has been developed. So both mainstream users as well as colorblind users can take the advantage of the take benefits from pictorial icons that has been developed.
Okay, thank you. And Elena, what do you think about that?
The my answer is similar. We are examining some extreme cases, and also, of course, the result can be used by persons who are not a part of the extreme cases. So if we make the design accessible and usable for persons who have more severe issues and impairments, then the same thing is also, of course, usable for persons who are not that in that category, but are dealing with some issues. So perhaps if we establish some, in my case, rules and recommendations for the design of an inclusive graphic for an interface in a vehicle, some of those recommendations are applicable and usable for, let's say, current models of vehicles that are being used by elderly, let's say, who have reduced sight but are still active drivers. So some of the features can be helpful to them as well. Examining the extreme cases is always the starting point, and then a great deal of those findings can be used for more commercial use and design.
Okay, great, thanks. And one more question: has anyone of you considered actually different types of maybe data collection that you use in your research? So, for example, such as eye tracking, which potentially could be very, very interesting for visual aspects of your work. So, especially for analyzing user interfaces, for analyzing, for example, visual interactions with products. So, has anyone of you maybe considered something like that?
I'm considering using the eye tracking and eye gaze tracking and eye tracking devices such as Kinect and eye tracker, but that is part of another research. That will be included in my thesis, of course, but this is not part of this paper. I have not included this in this paper particularly.
So same as us, we are also considering eye tracking. So the only we have is the interaction with fluid textiles on a head-mounted system. I don't found anybody who is willing to get all this data done, analyzed and standardized. So therefore, it's more about maybe think about later on representing pictures on a panel that we use a remote system and see where do the people really look at, which pictures are working, which not. So it's more the next step. We're using eye tracking. The head-mounted interaction one we can't see at the moment in the setup, which will work for us to find out the right data we need to have.
Okay, and then just one question related to the trend. So the last question, what I would like to pose is actually, Bastian mentioned that in his paper, in his manuscript. And there are actually a lot of initiatives that try to let's say, increase objectivity, try to base a lot of these things, a lot of let's say, analysis on perception based on big data, and also to try to incorporate artificial intelligence with it. So do you think that actually artificial intelligence and actually so extensive data collection could help in your research in the future?
we are thinking about it. But again, it depends a little on the market we're looking at. Especially for fashion, we are a little bit reluctant because fashion is turning so much around and quickly about what people like and what they don't like. So therefore, and at the end, if you talk about perception, it's about a subjective feeling. So therefore, we are not sure if the algorithm will last long to go all the time. Trust if we go on more slow moving animations, and it could be an option. This is our opinion for fashion and for tech growth.
Okay, thank you. I think we have minor problems with connection, but I think in general we all hear you. Yeah. So, are there any comments or some final words from each one of you? Would you like to say something for the end? Are there any questions from the audience? If not, then I would like to thank you all for participating, for great questions, for nice discussions, and I would like to thank also especially for two presenters once again for presentation and demonstration of your work. Yeah, let's go to let's take some break and visit some other sessions, and hope you will enjoy the rest of the day today. Thank you very much. Thank you all, and thank you to the audience as well.
Thank you.
Thank you.
Thank you.
Thank you very much.